Karthik, co-founder of Sorella, and I will be talking about the MEV-Aware future, which is my hypothesis for where apps will go as the space kind of evolves. Cool. Yeah. So quick structure. First, we'll talk about MEV generally, then the attribution problem, which is the problem with most MEV mitigating designs right now, and then the sovereign endgame, which is my thesis. Cool. So the canonical example is a sandwich. Basically, an uninformed user submits a naive order. It has a naive slippage, and the profit maximizing arbitrage for sophisticated players is front run, have the victim swap, and then back run. Right. So in scenario one, assume that this doesn't happen, and the user's transaction is the first to touch whatever DEX they're swapping on, and assume like in the block prior, this DEX was properly reset to whatever the true price was. So now the user's actually getting pretty good execution quality, right? They're basically transacting against this DEX, paying the LPs a fee, and then incurring some slippage, but nothing that is too major, especially no liquid DEX. In scenario two, now you have searchers who monitor the mempool at all times, see that there's value being extracted because the transaction to the slippage that was unfavorable, and now they exploit it, right? But obviously this is a deterministic opportunity, so there is going to be a market to actually be the one to extract from the user, and this is going to the builder who eventually goes to the proposer. So the idea is that this opportunity is captured based on the info we have in place, but it's not being redirected properly. The users are the one who gets screwed over. It's simple. Okay, the next type is MEV created through information, and the classic example is sex text. So this is a function of consensus systems generally, where consensus takes time. In the time of consensus, now information is accruing outside of the chain, right? In centralized exchanges in this example, but it could be arbitrary in any given context. And whenever you have this asymmetry of information, now there's a market to be created to touch the stale chain state of the previous block. In the case of sex DEX, there is a market created to be the first to swap through a pool, because the first to swap through any given AMM, if there is any volatility realized in centralized exchanges, will essentially be taking LP liquidity at better than true prices, which is a deterministic arbitrage for sophisticated players that have inventory both on centralized and decentralized exchanges. The idea is that this is a more centralizing opportunity, but it's also captured given that the sex DEX arbitrageurs compete against each other for the actual right to be the first to touch the DEX state, the stale state. So what is the attribution problem, and basically whose MEV is being created, but where's the value actually going? So we see right now that these are two discrepant entities, right? We have PBS in place that basically realizes that building blocks and MEV generally is a very sophisticated process that is going to centralize, but it is a property of Ethereum broadly, and like consensus systems with state and with transactions that that have conflicting state access. So the idea is that let's have this value kind of compete away in a competitive market and moved up the chain to a more decentralized party, which is the proposer in this case. So at the bottom of the totem pole, you have the passive LPs and uninformed traders. They're getting arbitrage left and right. The passive LPs by the sex arbiters, the atomic, or the uninformed traders by the sandwichers. These go to the builders, and then the builders then bid up in a block auction to the proposer. This is theoretically efficient because all the value should be captured. That is kind of escaping the system in these MEV opportunities, but the issue is that it's one lump sum, right? So we lack the granularity to be able to say, okay, we have this much value that has been extracted in the past block from MEV, both on-chain deterministic, but also off-chain informational, and we can aptly pinpoint who the adversely selected parties are and redistribute it accordingly. Now it's just going to some opaque third party who is the proposer, who's not really in this kind of value flow system, right? It's basically value leaking in this auction that could be being redirected to parties that are affected to another third party that's not affected. And there's an analog too in the L2 space where if you consider shared sequencing, and the current designs where it's basically like execution tickets. So the shared sequencer and each L2 is going to auction off some future on their block space to sequence along with all the other L2s. Now you have the same issue where the value flows in the protocol by selling these tickets and burning them, or distributing the value back to token holders, but the actual MEV that is giving value to these execution futures is the result of an adversely selected party on chain that isn't being compensated appropriately. So why is this like bad incentive-wise? If you really squint your eyes, it's basically like, from the user's perspective, they send an order to the mempool. There's a competition that occurs where all of these arbiters are competing, and they know the value of the opportunity and how much to extract. But this all goes to the stakers. So not only are they getting screwed over by like the actual protocol itself, but they're actually paying stakers of the protocol to be screwed over by the protocol, which is just not sustainable. So this is why I think that all applications will move to being sovereign applications. What do I mean by this? Let's first get a few definitions out of the way. So an attributable app is something that I define as an app which is able to uniquely determine parties in the application, players in the application, each of their kind of competitive strategies in this game, and based on the outcomes of the game, decide who gets compensated what in a fair market equilibrium. So the easy example is a batch auction with uniform clearing price, right? This is basically saying that all of the asking bid side liquidity is going to be kind of piled together, each at their respective price, and then everything in the entire batch is going to be executed at the uniform clearing price. So the idea is that uninformed swappers can just send their orders willy-nilly, but the market makers will be incentivized to kind of squeeze this back to whatever the true price is, because they're always competing against each other to execute the batch at the best possible price. And as they continue to compete, this will go and converge to whatever the true price is. Another example is MEV taxes. This is basically an implementation in like a priority ordering model, where if you, as an application, are able to say, look, there's extractive behavior that can happen within my application, and it will be the result of users paying a priority fee to be sequenced first. I'm actually going to tax the sequencer to redistribute some of that priority fee back to me as the application, and then I can redistribute that among the adversely selected parties. So the idea would be, if you have a DEX and you're in like a priority sequencing paradigm, now you can charge a tax on the sequencer and then redistribute whatever the priority fee that was paid pro rata back to the LPs of the first swap that transacted to the pool. And this should essentially solve LPR in theory. What these apps try to maximize is participation and then minimize barrier to entry. So that's going to be the most possibly competitive auction. And this is going to result strictly in the best prices for users. And the issue with attributable apps right now and how MEV can still be extracted is the second order effect, right? Where now if you have composability between apps, even if they are attributable, now there's some value in sequencing both together, or being the first, composable transaction in the block that touches two different attributable apps, and you pay some priority fee for this. How do you determine which app gets what? And this is actually a computationally hard problem, right? So now you have like an emergent dynamic of applications that are attributable setting their taxes kind of in conjunction with other attributable apps that they could possibly be sequenced with. And this is not the angle anymore. So the other definition is a sovereign app. A sovereign app is an app that locks their state and thus is not composable with any other app. And they order themselves naively or strategically. A good example mental model to have for this is like L2s, right? So they're naively ordering based on like a priority yes model, some based on a first come first serve model. Either way, they are non-composable in that they are submitting blobs to Ethereum for settlement, but they're not inherently composable with other L2s because they have to wait either timeout period or like the ZK window, right? So they eventually settle onto Ethereum, but are their own silos of state, which give many beneficial properties. What I think is going to be the end goal of applications generally, and the most performant applications are those that are both sovereign and attributable. This is the golden intersection, in my opinion. As we mentioned in the MEV tax example, the problem of attributability without sovereignty allows leakage through composability. But the bigger problem of sovereignty without attributability, which is the case of L2s right now, is that more fairer applications can always be built on top. right? The L2s are basically too big to be able to attribute whose MEV, or how to distribute MEV. This is like the problem with most shared sequencing designs, where if you auction off the execution future to some L2 block space, this will go back to the token holders, but now you still have like the same system we have right now in PBS. This is kind of an opaque party who's getting the proceeds of a user that's getting screwed over on the L2 itself. And they computationally cannot determine whose MEV this is without fairer applications who can built on top of the L2. So that's why I think this is the golden intersection, and market forces will inevitably lead to this as the outcome, right? All else equal, this will give strictly better prices for users because it is the most competitive and the value is flowing back to them, despite them being uninformed. And the other benefit is that it's very easy for solvers. So solvers can only focus on one specific sub-game, get very good at that game, and compete heavily in that game, and essentially be on the same playing field as like other integrated solvers, searcher, builders that are doing everything, right? Right now, it's not feasible for me to only be a success arbitrager on Ethereum and USDC. Given that if I am better at pricing than any of the integrated builders, they have the capability of just pricing me out of blocks, right? They can censor me, and now I am unable to compete in these opportunities. But if we have an attributable and sovereign app that is only for this pair, now I am basically competing in the auction with them on the application-specific auction level, and this application then posts whatever the transaction bundle is to the L1, but I will be able to beat them based on the application logic itself. The other benefit for applications generally is that this monopolizes very easily. So as soon as you reach PMF as an application and you control your own state, now there's kind of this like pinwheel effect, this positive feedback loop that happens where everyone else on competing apps that have composability with each other and are presumably being extracted, they're going to move over in terms of liquidity or use to your application. And now you not only have the deepest application in terms of liquidity and the one with the most usage, but you also have the lock on your states that makes it so that no other competitor can really spin up and then kind of take your users via extracting through composability. So here's an example of like a possible future where this is really beneficial, right? So on the left-hand side, sorry, it's probably a bit hard to see, but on the left-hand side we have one application which is spot liquidity, and this is gated by a quorum certificate of application-specific restated notes. So all the users submit their orders, which are like permit twos, to this application off-chain consensus mechanism running in parallel to whatever the settlement chain is. And we also have searchers that are monitoring this, kind of all the order flow that's circulating within the nodes of the system, and they are placing orders at more performant prices to make the batch execute at the best possible price, competing against each other. So now, once the batch is finalized, then the nodes sign off on, okay, this is a canonical batch. They're able to access the contract on the L1, which is gated by a quorum certificate, let's say 2/3 of the nodes signing off that this is a good batch. And now they have inclusion in the spot, right? Now on the right-hand side, we have a perpdex, and this is going to be a centralized sequencer. Same kind of thing, where the users send to the centralized sequencer, the searchers monitor orders that the sequencer is getting sent by users, and they are competing against each other to fill them with the best prices. And the centralized sequencer is the only one who can touch the smart contract on chain. They send this batch of finalized transactions that are sequenced by perhaps some fair ordering mechanism, or in this case, uniform clearing again, for fair ordering, maybe like Demus or something, right? And they send this to the L1, and now this is in the same block as the other application, but the beauty is that both are commutative with each other, right? There's no extraction that can be done by ordering one ahead of the other, or putting them in any other position in the block because they control their own state. So they're block agnostic. And as a result, they only have to pay whatever the base fee is, plus epsilon times the number of orders in the actual bundle for inclusion. As a result, if all applications move to this future, then the proposers are only going to be getting whatever the base fee is, plus however many transactions were included in their block, which is what they should be getting, because what they're selling is essentially block space, and this is the exact amount of block space that they're selling. Some open questions. So the issue with this design currently is that a user can equivocate, right? If you have a batch and everything is kind of sequenced properly, but the user, wants to DOS everyone or is not happy with their order, they can basically send a transaction with a higher priority fee that wipes out all of their funds. And now they can't pay for this, so the entire batch reverts. Obviously not desirable, and a big issue right now, they can also send an order with like the same nuance, for example, that would invalidate their order for the batch. But there's a lot of emergent infrastructure being built around making sure that the user can equivocate in this in terms of like intent design, stuff of the sort, that I think will hopefully see PMF soon, or hopefully be built soon, and then integrated in the system like this, where now it's not feasible to DOS a large bundle at scale. The other reason I'm not too worried about this is that to actually DOS this bundle, you would have to bid a priority fee that is more than the aggregate weight of the bundle, right? So you'd have to say like, I'm willing to pay however many transactions are in this bundle plus or times the base fee. I have to pay that in priority fee to actually DOS this. And that is just a losing proposition at scale for the person who's trying to DOS. The other interesting thing is parallelizing block load, right? So if you squint your eyes, this kind of looks like a state lock on whatever block space your application, state space your application touches. This is a lot of very similar to a lot of distributed systems literature that allows you to have parallel read writes from databases generally, right? So is there a way where we can build really, really large blocks efficiently where all applications kind of silo their own state, and you have an optimistic model where all the builders just assume, okay, this application is in a silo state, they just send me shreds of whatever their application-specific transactions are, and then we can build the entire block in parallel. And then the other thing is precons for app space. So this is kind of like the problems all the L2s are facing right now is, when do we want to send our blobs? How do we actually price the precons given whatever look ahead we're trying to do? How is this affected by any sort of fluctuation in the base fee price, etc. And how do we get users in our application to be able to accelerate this process should they want to? These are issues that are all being ironed out. I think the design space, especially for pre-comps, is very nascent. But an interesting application of stuff that the L2s are focused on that I think eventually applications will be more so focused on. Anyway, an optimistic future for kind of reducing and eliminating MEV generally. Thank you.
Thank you. Yeah, because we have two market makers here. I don't know if market makers have any questions.
Yeah, I just wanted to focus on one of the points that you made about how under this new paradigm that Sorella is enabling, solvers that have a particular kind of competitive edge, let's say in sex arbitrage, would not be able to just be priced out by those that may not have as much of an edge, but perhaps they just control a lot more funds or are able to kind of take more of tighter spreads, for example, right?
Right. So the reason is because you are limiting the scope of the opportunity, right? Right now the opportunity is across the entire block generally in terms of building the entire block. So me as someone who only wants to hold inventory on Ethereum and USDC, I can theoretically compete for this opportunity to just arb that pair in a sex fashion. That being said, if I ever encroach in terms of Beaver builds total P&L, and they think that if we just take an immediate loss and price them out of the next month of blocks, then it won't be an issue in the future. They can do this, right? Because they are able to actually build the entire block. But in this system, in the paradigm that Sorella enables, now you modularize each specific option. So there would be a separate option for just ETHUSDC, where I would be as competitive as SCP in being able to extract them.
Got it, makes sense. And one more point about the auctioning system as well. So I think there's also an implication that the Sorella network itself would need to extract some kind of a value from proceeds from auctions as well, right? So how much is the network supposed to be taking? Is that dynamically adjusted? How much are they kind of sharing with the users? You're just what's kind of the rationale behind, I guess, how you think about pricing, how you're kind of making everything more still cost effective or worthwhile for all parties to kind of participate.
Right. I think you get an inherent unlock with like restake ETH, right? Because the ETH is already staked that's being used as collateral to secure the system, and that's getting yield through staking. But you can add more yield on top of that with just like a little bit in terms of how much you're paying the validators for holding this auction properly. And they're more than happy to do so because the actual compute costs of like the hardware necessary to run the sidecar is very minimal. So you just have to be able to pay a bit more than that and actually come out to maybe like 0.5% APY, right? And take that off of either I think like sound design for that is just whatever fee is being paid by swappers and market makers to the LPs to transact in that liquidity, take like 5% of the total LP fee and then pay it to the proposers.
Got it. Thanks.
Thanks. Any more questions? Yes, sorry.
So on the previous slide, you said the DOS cost is like gas use times base fee. Why?
Oh no. So it's the DOS is you have to essentially submit a transaction with the same nonce as the one included in the bundle, right? But you have to have this sequence ahead of the bundle. So the builder is getting whatever the base fee is times the number of transactions in the bundle from the bundle itself. But to get your transaction sequence first, you have to pay that amount plus a bit more to actually DOS the bundle, right?
But this gets burnt, no? Like the base fee gets burnt. Like it's not a incremental value add.
What do you mean?
Like a builder is not going to care about what the base fee like amount is, right?
Yes. Presumably, you're right. Basically it's weird. Let me think then. Then what's the incentive right now to fill up blocks?
Like priority fees.
What's up?
You're going to care about priority fees, right? Like
It is strictly priority fees.
yeah.
But then why does any builder include transactions that like don't touch contentious state?
Because they pay like marginally non-zero priority.
Okay, then same like so same idea, right? Where let's say they play epsilon as a priority fee, right? And now the user would have to pay like number of transactions times epsilon to actually DOS this, right?
Sure, but then the like cost to attack is way lower, right? It's just like the priority fee that gets paid on top of the.
Well, it's linear in any argument, right? Where in your case it's like okay, they're paying like epsilon as a base fee, but this is essentially the same case as if the base gas was just epsilon, right?
Right, okay.
But I think like, I mean, to your point, there will be, I mean, at least from our perspective, right? The idea is that block building generally is combinatorial and they have a lot of stuff to search through. It's very easy for them to just say, okay, this application is not going to touch any contentious state, and I don't even want to bother sequencing it or perhaps having like a user DOS over the same rounds. So I'm just going to sequence it at the top of the block, right, before anything can happen with any of the accounts that are transacting elsewhere, but also in this batch. And then they can do the actual combinatorial search over the stuff that matters. But you see like the argument of why it's essentially the same?
Sure. I mean, it just sounds like it's a lot lower.
Right. But then then you can
costs, right?
then increase the epsilon pay.
Right, sure.
Yeah.
And the other thing was you mentioned a lot of, maybe I just missed it earlier. You mentioned a lot of repayments to adversely selected participants. What is an adversely selected participant in this definition?
Right. So in the case of like a swap, there would be the person getting sandwiched, right? But the repayment is a function of the design of the system itself. So if you have a hybrid order book AMM that executes everything at uniform clearing price, now it's impossible to sandwich because the actual sandwicher is being executed at the same price as the user, right? So the competitive game is not a battle for block space that then leaks value to the proposers. Rather, it's a battle to fill the user at the best possible price. And if you kind of tack in the underlying pool liquidity here, then you execute everything at uniform clearing price. So now it's not only very difficult and impossible in like a competitive market to extract from the users, you also are saving the LPs at the same time, making sure that they're transacting at whatever this uniform clearing price is that's being competed up to by the sophisticated players to whatever the true price of the opportunity is.
Okay, sure.
Thank you. Any more questions? Yeah, thank you.